Hello, hello. Welcome back from intermission, everybody. Find your seats, grab your beer. My name is Sinclaire Manning, also known as Major Merger.
And my name is Jackie Champagne, also known as What a Merger Jr.
And we're here to bring you this month's top news stories in astronomy. But first, I will say, yes, this is Jackie. This is not Brian, who typically does the news with me. Brian deserted us tonight to go see a Weird Al Yankovic concert. I mean, I guess that's a good reason. But I'm very happy to have Jackie as my co-host. We're actually academic sisters. We have the same research advisor. And we both have cool merger names. Hers is a bit cooler, if I'm honest. But really happy to have her on stage with us.
But hey, Sinclaire, we're both white and nerdy, am I right?
How dare you? I'm insulted by that. Okay, on to the news. Down. Nope. Up is down. Down is up. Down is up. Brian normally holds this, not me. All right, first up. So researchers using the Atacama Large Millimeter Array, also known as ALMA, observed the earliest combined signals of oxygen, carbon, and dust from a galaxy in the universe 13 billion years ago. So by comparing the different signals shown here on the left in this beautiful image, the team determined that the galaxy known as B14 65666 is in fact two merging galaxies, making it the earliest example of a galaxy merger to be discovered so far. So in the image, red is dust, green is oxygen, and then blue is carbon. So data analysis show that the emissions are divided into two blobs, and previous observations with the Hubble Space Telescope, which are these two white blobs, they revealed two star clusters within the system. So now with three emission signals detected by ALMA, Takuya Hashimoto at Waseda University in Japan and his team were able to show that the two blobs do in fact form a single system, but with different speeds, which indicates that the blobs are two merging galaxies. And Jackie and I actually just heard Takuya talk at a conference in Portugal a few weeks ago about this system, so that was pretty cool. So the research team estimated that the total stellar mass of B14 65666, they got to get a better name, is less than 10% that of the Milky Way. However, it's producing stars 100 times more actively than the Milky Way. And really active star formation such as this is another signature that it is a galaxy merger. So the detection of radio waves from three components in such a distant object demonstrates ALMA's capabilities to investigate the distant universe, and Hashimoto plans to continue using ALMA to search for nitrogen and carbon monoxide to further understand this intriguing system. Up is down. Sorry, down is up.
Okay, so before I talk about Saturn, I need to give you a very important vocabulary lesson, which perhaps the youths will be familiar with. The word is yeet, Y-E-E-T. The definition of yeet is to throw with great force. So perhaps if one had an empty soda can and you were to throw it into a garbage can across the room, you would yeet it. But you have to say it really forcefully, so it's yeet. Okay, so moving on. You're going to need to remember this word for my stories. So if y'all remember Cassini, the spacecraft that was sent to Saturn in 2004 and remained orbiting until 2017, yeeted itself into Saturn's atmosphere. It was a really sad day, but before it yeeted into the atmosphere, it has sent back so much data through its dive between Saturn's rings, which was appropriately called the Cassini's grand finale, and scientists are still studying all this data that's coming back. So a recent paper led by senior research scientist Matt Tiscareno of the SETI Institute was published in Science, and it's giving us a new detailed look at Saturn's rings. So the left image here is showing a mosaic from the Cassini image, and then this is zoomed in on a gap between the rings, and this moon that you're seeing over here is a small moon called Daphnis. So Cassini was able to achieve ultra-high resolution of less than a mile per pixel. And Cassini's final images, may he rest in peace, revealed much more complex structure in the rings than we thought, suggesting that, much like how we felt about high school boys, they are not nearly as smooth as anyone thought. Happy Tuesday. Okay, so anyways, the rings are seen to have clumpy or patchy textures, and especially near the gaps between each ring, these small moons can kick up waves on the edges of the ring. So, like I said, you're looking at Daphnis here, whose orbit is clearing out an area called the Keeler Gap. And its gravity is able to kick up waves of particles so fine that it almost looks like smoke, which is how it was described in the paper. So you're seeing on the right, these particles look close to sand dunes, which is just really, really cool. We've just never seen any structure like this. So scientists are really unsure what exactly governs the shape and size of these planetary rings, because the mass, the particle size, and the particle composition all likely play a role. So this offers a small window into the physical processes behind solar system formation, where planetesimals are also thought to clear out their orbits within protoplanetary disks. Another result that came out of the last Cassini study was from the visible and infrared mapping spectrometer, which revealed new information about the chemical composition of the rings. Especially in the outer A ring, they did not find strong evidence for water, ammonia, or methane ice, and no evidence for organic compounds, which is a surprise since the inner D ring is known to harbor organic material. So we have a long way to go in understanding Saturn, but, you know, rest in peace, Cassini. It did a great job.
Can we just yell that throughout the rest of the show?
Yes.
Okay, cool. All right. I think some of you might like this one. So, astronomer Vera Rubin, best known for her pioneering research on dark matter, will lend her name to a new telescope if a bipartisan bill passes Congress and gets presidential approval. So, that last part might be a little tricky, but we'll see what we can do. The bill, dubbed H.R. 3196, was introduced a week ago and would designate the Large Synoptic Survey Telescope as the Vera Rubin Survey Telescope. And on the left is a artist rendition of what it should look like when it's all done. So Eddie Bernice Johnson of Texas, the chair of the House Science Committee, and Congresswoman Jennifer Gonzalez Colon from Puerto Rico co-introduced the bill. And while Vera Rubin passed away in 2016 at the age of 88, the bill's text notes some of the challenges she faced as a female astronomer in a male-dominated profession. It also describes her significant contributions to astronomy and her pioneering work. So in 1970, Rubin published measurements of the Andromeda Galaxy, and that work, combined with other research describing the rotation of stars and spiral galaxies, provided some of the best evidence for the existence of dark matter. The LSST wide field instrument is designed to image the entire sky above it every few nights, and it's currently under construction in Chile and is expected to come online sometime in the 2020s. So along with scanning for asteroids and looking for possible interstellar objects, observations from the LSST may also help to answer some questions surrounding dark matter and dark energy, since it will observe billions of galaxies over time, which is rather fitting given Rubin's research interests. So fingers crossed that it does get named after her, because she definitely deserves it.
So that's exciting news for the future, but I'm sorry to use my AoT News debut as the bearer of bad news, but it's time for another moment of silence. Not for Cassini, but for the Spitzer Space Telescope. So on May 14th, Dr. Lisa Story-Lombardi, the Spitzer project manager, announced that the telescope will transmit its last science on January 30, 2020. So Spitzer was yeeted into space in August of 2003. And it was equipped with a primary mirror of 0.85 meters and 3 infrared instruments. It was the first spacecraft that was put into an Earth-trailing orbit, meaning that it orbits the sun, but it drifts behind the Earth a little bit, keeping a cool distance. It was originally planned to only be a 2.5-year mission, and it was equipped with enough liquid helium to cool its instruments to a few degrees above absolute zero. This coolant lasted until 2009, but at this point, most of the telescope became unusable, with only the 2 shortest wavelengths of the instrument IRAC operating since then. But nonetheless, 10 years past its expected end date, this little baby geriatric telescope has revolutionized our view of the infrared universe. It was the first telescope, for example, to directly detect an exoplanet, HD 209458b, and as Sinclaire pointed out, please come up with better names. This happened in 2005. It also discovered several of the TRAPPIST-1 planets, and together with Hubble, it's imaged some of the most distant galaxies ever seen in the universe, and it has offered the opportunity to study the dusty star-forming clouds, both near and far. It gave us beautiful insights into dusty supernova remnants, like the image of Cassiopeia A that we've now seen several times tonight, but this is adding on top of the X-ray also this Spitzer infrared image, showing the power of multi-wavelength astronomy used together. It also discovered an additional ring around Saturn, so Spitzer has done a lot in its lifetime. But as the spacecraft drifts further away from Earth, much like George Clooney in Gravity, but less beautiful, it will find more and more difficulty recharging its solar panels and sending data back to Earth. So if the telescope goes into what's called safe mode, we may never hear from it again. So NASA will be switching off the controls itself so we can end this mission in peace. No yeeting into a planet this time. NASA wants you to follow the hashtag Spitzer Final Voyage on Facebook and Twitter for updates on this bittersweet goodbye. And Spitzer has really paved the way for the next great infrared mission when the mystical launch of the James Webb Space Telescope will occur. Yeet.
All right, I've got another ALMA story, but this time we're looking at planet formation instead of galaxy mergers. So a new high-resolution image from ALMA features a protoplanetary disk with an isolated outer region composed of an intricate system of thin rings and gaps. So we're interested in this outer triplet system, I guess you could call it, of rings. So, so typically when we look at these protoplanetary systems, we're used to seeing the outer ring as like kind of a smooth distribution of dust or material instead of these clearly defined gaps and rings that we see here. So the discovery of these structures allowed a research team led by Sebastian Perez from the University of Santiago in Chile to explain it with a rather straightforward interpretation as to how these rings came to be. So according to their work, a single migrating planet, about 10 times the mass of Earth, is orbiting around the host star and sculpting the dust particles into multiple narrow rings. So what's shown here is the new ALMA observations of HD 169142, which is a protoplanetary disk 370 light years away in the constellation Sagittarius. So less than a year ago, the D-Sharp program unveiled several new ring systems, which we did show here at AoT during the news segment, but this shows the first evidence of planetary migration in disk observations based on the fact that this middle ring in the outside is closer to the center than the outermost ring. So the idea here is that as the planet has carved out a ring and then is migrating, that it moves closer to the star, it's shepherding in that middle ring with it. So you can imagine it's moving, and as it's going closer into the host star, this middle ring is also moved closer in, and that causes this distance between the two. Hopefully that made sense. So future work will continue characterizing these super young exoplanets and modeling the various ways that these discrete ring structures may be formed. Last up.
And finally, for astronomy not in the news, as part of our celebration for Pride Month, we would like to highlight a special social media project called Unique Scientists. So this is a project aimed towards celebrating the diversity of scientists in many different STEM fields. So Unique Scientist was born from a tweet by Vera Rivera, which included a selfie and the description, "Time to destroy the stereotype of how a scientist should look like, #BeYourself," which seems like a lovely tweet and like no one should have a problem with it, except a cruel response tweet said, "Just because you are unique does not mean you are useful." What? That was my reaction when I read that tweet. So, if you are a loyal AoT attendee, or if this is your first time here, you will see that no two space cadets here have the same story of how we became scientists, and none of us look alike. Namely, not a single one of us looks like Doc Brown. The inside of my frazzled brain looks like him, but really, astronomers can look like anyone, and most of them can't be bothered to wear anything nicer than cargo shorts and graphic tees, even to conference dinners, so, you could really be anybody. So Unique Scientists exists to highlight STEM scientists and communicators, offering interviews with biologists, chemists, plant scientists, and of course our very favorite astronomers. So a recently posted highlight was this one of Taylor Hutchison, who is an astronomy PhD student down the road at Texas A&M. She studies some of the most distant galaxies in the universe using the Keck telescope in Hawaii. And she helps organize the Astronomy on Tap in College Station if you're ever out there. And since we're giving her a shout out, she is now required to finally come here and give a talk. So feel free to reach out and tell her that. So Taylor and many other astronomers are helping us tackle these stereotypes that astronomers are just old men in sad offices, although those definitely exist too. You can follow Unique Scientists on Twitter, Instagram, uniquescientist.com, and they also have some dope merch, stickers, etc. If you're also a scientist, you can apply to be highlighted, or you can support Unique Scientists by being a #unique ambassador. And here at AoT ATX, we want to celebrate all people who have a love for space. So we definitely encourage you to check them out and continue to show the love and support you have always shown for every member of Astronomy on Tap. Thank you.
And that's all we got for you this month. Thank you. Big round of applause to Jackie again.